Okay, let's have a look at this. Determine the positive values of x that satisfy the equation 2 plus 2 log base 5 of x equals log 5 of 24 plus 10x. As I was reading the question there, I got extremely frustrated that the positive values of x determine the real values of x that satisfy the equation, because it's in order for this thing here to exist, log base 5 of x to exist, we need x to be a positive number. So that's something that is a really good way of differentiating good students from excellent students, is when you go back and check things like logarithms. Anyway, they've given us a bit of a hint there that we only need to consider the positive solutions. Nonetheless, this is just using some standard log rules, I think, from the looks of it. Let's make this a log base 5 of x squared. So we've got 2 plus log base 5 of x squared equals log base 5, 24 plus 10x. Actually, also, I noticed that this is a not find the number of solutions, it's solve. So find the values of x. So I could, if I wanted to, just sub in some values of x. But none of these values are particularly nice to deal with, so I'll leave it as it is for now. Okie dokie, cool. Let's continue. So how do I go about this? I'm probably going to bring this log onto this side. So I've got log base 5 of, and if I use a log rule, x squared over 24 plus 10x equals minus 2. And now if I do 5 to the power of both sides, I can get rid of the logarithm. So x squared over 24 plus 10x is 5 to the minus 2, which in other words is 1 over 25. And now cross multiplying 25x squared minus 10x minus 24 equals 0. And now I'm just solving this quadratic. Will this factorize nicely? There's potential for it. So here's a nice little trick if you've not seen this before. If you've got a quadratic and it's got integer coefficients, in fact, if you've got any polynomial with integer coefficients and you want to know if it has any integer solutions, so if this quadratic has any integer roots, all I need to do is substitute values of x in that are factors of this constant term. So in this case, 24. So that could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, or plus or minus 24. So it doesn't really help in this case that the 24 has a bunch of factors. But also looking at the solutions here, I know it's not going to have any integer roots, so it's probably not worth doing that. Another thing I could do is if I want to know if this has nice rational roots, so roots where the roots are rational numbers, I can just look at the discriminant. So this is going to have rational roots if and only if the discriminant is a square number. And so the discriminant here is maybe slightly easier to calculate. That's going to be minus 10 squared minus 4 times 25 times minus 24.